All right, tomorrow in class, we're going to be working on simplifying radicals. So the multiplication chart will be a big help when we're simplifying radicals. If you look at all the numbers that go across the diagonal, those numbers are going to be called perfect squares. And they're called perfect squares because they have the same factors. 3 times 3 is 9. So the square root of 9 equals 3. Look at 25. My factors of 25 are 5 and 5. So the square root of 25 would equal 5. If I look at 81, my factors of 81, 9 times 9. So what would the square root of 81 equal? Now we want to use these factors to simplify radicals. So if I want to find the square root of 20, I'm always trying to keep these perfect squares in mind. Once I have a factor that's one of those perfect squares, I'll stop with that factor. So if I want to find the factors of 20, I locate 20 on my multiplication chart, which is here. So I know my factors of 20 are 5 and 4. So 5 times 4 equals 20. Now 4 is one of the perfect numbers on the diagonal. I know the square root of 4. 5, the only factors of 5 are 1 and 5. Neither one of those are perfect squares. So the square root of 20 is equal to the square root of 5 times the square root of 4. So I want to simplify that. So I'm going to say, okay, there's no square root of 5, so that's equivalent to 1 times the square root of 5. We know the square root of 4 has to be 2. So that's equivalent to 2 times the square root of 1. So to multiply like we did in class today, we're going to multiply the outside numbers. 1 times 2 is 2. And the inside numbers, 5 times 1 is 5. So the simplified version of the square root of 20 is 2 square roots of 5. Those are equivalent radicals. So let's look at another number. Let's look at the square root of 90. So again, I want to keep those perfect squares in mind. So I'm going to look on my multiplication chart for my factors of 90. So I'm going to find 90. So 90 has factors 10 times 9 equals 90. So I'm going to make my factor tree 10 times 9. If I look for 10, factors of 10 are 5 and 2. So 5 times 2 is 10. Now I don't find factors of 9 because I know the square root of 9 is in our perfect squares. So I'm going to rewrite this to be the square root of 5 times the square root of 2 times the square root of 9. I know I cannot simplify the square root of 5, so that's 1 times the square root of 5. I cannot simplify the square root of 2, so that'd be times 1 square root of 2. And I can simplify the square root of 9 because it's a perfect square to equal 3, so let's say 3 square roots of 1. So to get my simplified answer, I'm going to multiply all the numbers outside. 1 times 3 is 3. And I'm going to multiply all the numbers inside. 5 times 2 is 10, times 1 is 10. So the simplified version of the square root of 90 is equal to 3 square roots of 10. Now let's look for one that's a little bit more difficult, the square root of 75. Again, I always want to keep these perfect squares in mind. When I look at my table, I cannot find 75 anywhere on my table. So what I'm going to have to do is I'm going to have to think, what numbers do we know of as 75? Well, I think of money. How do you make 75 cents? Well, 3 quarters make 75 cents. So 3 times 25. And notice, 25 is one of my perfect squares, so that's good. 3, the only numbers multiplied 3 is 3 times 1. So that won't go any further. So to simplify that, I'm going to say the square root of 3 times the square root of 25. That's equivalent to the square root of 75. If I rewrite it, 1 times the square root of 3 is equal to the square root of 3. I know the square root of 25 would give me 5. So say times the square root of 1. And if I multiply by multiplying the outside numbers, 5 times 1 is 5. And 3 times 1 is 3. So 75 is, square root of 75 is simplified to be 5 square roots of 3. Last example. Again, we're simplifying, so we always want to keep these perfect squares on our mind. So 160. I cannot find 160 anywhere on my chart, but I know it ends in a 0, so 10 has to be a factor. So 10 times what would give you 160? 10 times 16. Well, 16 is one of our perfect squares, so we stop with 16. What numbers multiply to give me 5 or 10? 5 times 2. So I can break 10 down to be 5 times 2. So I'm going to say the square root of 160 is equivalent to the square root of 5 times the square root of 2 times the square root of 16. That would be all of my factors. So I'm going to simplify that by being 1 times the square root of 5 times 1 times the square root of 2 times 4 times the square root of 1, because the square root of 16 is 4. So my final answer is going to get, multiply the outside numbers, 1 times 4 is 4. And the inside numbers, 5 times 2 is 10, times 1 is 10. So we'll work on this more in class tomorrow.